It's a snowy day and you're pulling your friend along a level road on a sled. You have been walking at a steady 1.5 meters per second and the rope pulls up on the sled at a 30-degree angle to the horizontal. If the combined mass of your friend and the sled is 60 kilograms and you're pulling the rope with a force of 75 newtons, what is the coefficient of kinetic friction between the sled and the snow? Alright, so let's just start by drawing a free body diagram of this situation. So here's a dot that represents your friend on the sled. And of course, there's always going to be a force of gravity, so it always points straight down. So here's the force of gravity. And then the sled is on a level road. Okay, so that means the road is horizontal. So the normal force is going to be perpendicular to that, so it will be pointing straight up. You're also pulling on the rope with a force of 75 newtons. So since it's a rope, we're going to call that tension. So here's the force of tension, and it's at an angle of 30 degrees to the horizontal. So that angle there is 30 degrees. And then it does talk about the coefficient of kinetic friction, so that implies that there is friction. Now, even though you're pulling on the sled on this angle, the sled is moving along the horizontal surface on the road, right? So the sled would be moving to the right. That's the direction it's moving. And the force of friction always opposes the motion, so the force of friction would be going to the left here. Okay, the object is moving, so this would be kinetic friction. Alright, so those are all of our forces. Let's start to calculate what all of the values are here. Okay, so we'll start off with the force of gravity. We know force of gravity is always equal to mg. And in this case, they tell us that the combined mass of your friend and the sled is 60 kilograms. So the mass is 60 and g is 9.81. And so let's figure out what that is. I'm just going to type that onto my calculator. 60 times 9.81, and I get 588.6. Okay, so that's the force of gravity. We know that the tension, it tells us that you're pulling the rope with a force of 75 newtons, so that's our tension. Alright, so now let's find the normal force. So to find the normal force, we know that this object is moving only in the horizontal direction. It's not moving in the vertical direction. So that means that if up is positive, then F net in the y direction is equal to 0. So what are all of our forces that are acting in our y direction? We have the normal force, which is pointing up, so it's positive. So that's F normal. Let me just fix that a bit. Okay, so my normal force is positive because it's pointing upwards. We also have a tension which is positive since it has a component that's pointing upwards, but the tension's on an angle, so I'm going to write Ty. So that means the component of the tension that's in the y direction. So if I were to draw vectors here, I would say that this here would be my Tx, and this over here would be my Ty. Okay, so it's the y component of that tension that I'm adding to my normal force. And then I have my force of gravity. That one's pointing in the downward direction, so that would be negative. All of those together have to cancel each other out because, again, we know that the object is only moving in the x direction, which means it cannot be accelerating in the y direction. If it's not accelerating in the y direction, then that means that the net force in the y direction has to be 0. So the normal force is what we're trying to solve for. So I'm going to bring the other forces to the other side. So Fg becomes positive, Ty becomes negative. So my Fg, I already know it's 588.6 minus my Ty. Well, my tension is 75 newtons, but the y component of that is the opposite side of that 30 degrees. So the Ty then would be 75. I'm going to write it in here, 75 sine 30, because it's the opposite side of the 30 degrees. 75 is my hypotenuse, so Ty would be 75 sine 30. So that's what I'm going to write here, 75 sine 30 degrees. All right, so now I can just calculate that on my calculator. 588.6 minus 75 sine 30. And I get 551.1. All right, so that's my normal force. So now force of kinetic friction is my last force, but the question is saying what is the coefficient of kinetic friction? So I'm looking for that mu k. So my force of kinetic friction is equal to mu k times the normal force. And we know the normal force, but we are looking to solve for this mu k. So we really need to know what Fk is, the force of kinetic friction is first. And once we know that, we can solve for mu k, the coefficient of friction. So we can divide both sides by the normal force, and we get force of kinetic friction over normal force. So before we can find mu k, we need to find the force of kinetic friction, because we do know the normal force. We found it just above 551.1 newtons. All right, so how are we going to figure out what this force of kinetic friction is? There's no information. The only other piece of information that's here that we haven't used is this sentence here. You have been walking at a steady 1.5 meters per second. All right, so is this number 1.5 meters per second relevant? Not really. Really, the only relevant piece of information here is that it says you've been walking at a steady speed. Your speed is steady. Okay, so you're walking at this steady speed. Well, what does that mean? Your velocity is constant, because presumably you're walking to the right here in this diagram. You're moving this way, so your direction is constant. You're moving at a constant velocity, which means that you're not accelerating. So if you're not accelerating, you're not even accelerating in the x direction. So that means if we say positive is to the right, then the F net in the x direction is also equal to 0. And so it's just like what we did with the y direction. We could use that information to solve for Fk. So what are my forces that are positive in the x direction? We have the force of tension, but just the x component of it. So that's positive because it's going to the right. And then we have my force of kinetic friction, which is pointing to the left, so that would be negative. All right, so together those have to equal 0. Now if I solve for the force of kinetic friction, I get it that it equals to the x component of tension. All right, so I can think of moving the force of kinetic friction to the other side of equals. That makes it positive. So Tx equals Fk, or I can write it in reverse. Fk equals Tx. Well, what is Tx? Well, we can figure it out from our little triangle that we drew here, our Tx over here. That's the adjacent side of the 30 degrees. The hypotenuse T is 75 newtons. So Tx would be 75 cos, since it's adjacent, 30 degrees. So that's what I would be putting in for Tx, 75 cos of 30 degrees. And then I can just type that onto my calculator, 75 cos of 30 degrees. And I get 64.95. All right, so now I can use that to plug into my mu k equation. The question is asking me what is the coefficient of kinetic friction, so it's asking for mu k. So mu k is equal to the force of kinetic friction over the normal force. And we just found the force of kinetic friction is 64.95 newtons over the normal force, which we had already found was 551.1 newtons. Okay, so I can divide the two numbers, 551.1 on my calculator, and I get 0.1178. I'm going to just round that to 0.118. And there's no units here. The force of kinetic friction has units of newtons. The normal force has units of newtons. Those two units cancel out, so my coefficient of friction never has any units. All right, I hope that video helped. Thanks a lot for watching.